should be a false. True implies false would be false. Okay, all right, so I just had the wrong truth value. P was false, not true. Okay, so true or false is true, but if true, then false would be a false. Okay, let's go to a truth table, and let's do number 60. This one has P and Q. If that, then P or Q. Okay, so we need a P and a Q, column for that, P or a Q, and then the whole thing, P, if P and Q, then P or Q. So we need 4 cases, same 4 we're always working with. Okay, true and true is true, true and false would be false, false and true is false, false and false is false. True or true is true, true or false is true, false or true is true, false or false would be false. Now we're joining these last 2 columns with an or. So if true, then true would be true. If false, then true is true. If false, then true is true. And if false, then false is true. So notice this one is a tautology because all of the end results are true. Okay, I'm going to have to go to a new page for 64. This one is R and P and P and Q. If all of that, then P. Okay, so we need a P, a Q, and an R. P, Q, R. R and P, P and Q, R and P, and P and Q. And then we need the whole thing, and I'm just going to do it like this. Okay, we have 8 cases, so 4 true and 4 false. Splitting it in half. Then we do it by 2s. Then we go by 1s, so we alternate all the way down. Okay, now we want to join R and P. So true and true is true, false and true is false, true and true is true, false and true is false, true and false is false, false and false, true and false, and then false and false again. Okay, this time we're joining P and Q. True and true is true, true and true is true, true and false, true and false, false and true, false and true, false and false, and again. Now we're joining the last 2 columns with and. So true and true, false and true, true and false, false and false. All of these are going to be false. Okay, so now we're taking that and we're going to this first column. This is our antecedent. This is the consequent. So if true, then true is true. If false, then true is true. Okay, if false, then false is true. So all of these are true. So again, we have a tautology. Okay, let's do couple of others. Let's look at 76. They remind us that if P then Q is equivalent to not P or Q. So if the check is in the mail, I will buy you lunch. What would the equivalent be? The check is not in the mail, or I will buy you lunch. So the check is not in the mail, or I will buy you lunch. So that's 76. Okay, now 84 is where we use truth tables to show the two are equivalent. So P, Q, Q then P, not P, not Q, not P, then not Q. So we want to decide if these two are equivalent. So we have 2 true and 2 false, and then we alternate. If Q then P would be true, if true then true, if false then true, if true then false, if false then false. Alright, negating P we get false, false, true, true, false, true, false, true. So if false then false is true, if false then true is true, if true then false is false, and if true then true is true. So if we look at these two columns, we see they are the same, so they are equivalent. Alright, well, let's look at the circuits. We'll try a couple of those, and then we'll call it quits. Let's look at 92. Write a logical statement representing each of the following circuits. Simplify each circuit when possible. Alright, so for this one we have P, and then we have a split where we have the choice between R or Q. Okay, so we're starting with P, and then we have to do R or Q. And we'll do one last one. Alright, we've got a split at the beginning. We can do P, or we can go down and do P and Q or not P. Okay, so these are our little circuits. So we have P, oops, I think I copied that one wrong. That should be a Q up there. Q, so where is this? Okay, Q or P and Q or not P. And I'm not so concerned about simplifying. I think they say this one simplifies to just simply Q. But you can just stop with that point there. Okay, so I think you have enough information to complete the online homework now.